Hi there, my name is Miss Townsend and I love math. Welcome to Math with Townsend.
This video is for functions and relations students working on the year-end summative. It's question number 12.
Tritium is a radioactive isotope of hydrogen. If ingested, it has a half-life of about 10 days inside the human body. So obviously this is a half-life question, which is one of the exponential application questions. So we need to think about exponential equations, and in particular those half-life questions we've practiced. And we're told that if a person ingests 20 grams of tritium, we need to write an equation that predicts the mass after t days. So here's what we know. We know that the mass can be calculated by, and again, we're setting this up like every half-life equation or like every exponential equation, just adapted for half-life. So we know that we need to know the original mass that was ingested, and then the growth rate, in this case, is actually a decay rate, and it decays, it's a half-life, so only half of it will remain. And how long does it take? Well, it takes 10 days to get one half-life period out of the way, so t over 10 would be my exponent. And I need to specify here that t must be in days, and that's because the half-life period is in days. So this equation would let me calculate, based on how much someone ingests of this isotope, how much they would have after a certain number of time. Now I'm told that the person actually ingested 20 grams, so just substituting that in for my original amount, I would get this equation. So there's my equation. Again, here is the time after ingestion. 10 represents the half time period. So every 10 days, half of what was there remains. And we start with 20. So there's A. And in question B, we're now going to use that equation because it says how much would remain after 2 weeks. So this person ingested 20 grams, and what's going to happen after 2 weeks? So, I mean, really the only tricky thing to remember is that 2 weeks is 14 days. So we have to use 14, not 2. So making sure that we use order of operations properly. 14 divided by 10 is 1.4. So in my calculator, I'll do 0.5 to the exponent 1.4, and then multiply that by 20, and I'll get 7.6 grams. So make sure that you know how to use your calculator properly, because hopefully that's a fairly straightforward question. Part B of the question says, predict when the amount of tritium would drop to 0.1 grams. So in a way, it's sort of the exact opposite type of question from part B. In this question, I know what m is equal to. I know that I want to have 0.1 grams left over, and it's asking me when. In other words, what is the time frame that it takes to get here? So I need to take the same equation, but substitute in slightly differently because I know different information. So again, here's my equation. This is for part C. 20 grams to start with. It's a half-life question, and the equation was t over 10, and 10 was because the half-life is 10 days. And I'll just remind myself that t is in days. T is in days. Okay. So what we want is we want to end up with 0.1 grams. So now my equation looks like this. And I'm using now the 0.5 as a decimal instead of 1/2, just because I know I need to do some calculations. So this is my equation, and I need to now solve for t. Now t is in the exponent. So this sort of is a little more complicated than a lot of other equations you have to solve. So first of all, let's see how close we can get to isolating that exponent. The first thing I want to do is, if I'm multiplying the base by 20, I want to get rid of that by dividing both sides by 20. So on both sides of the equation, I divide by 20, so I get 0.005 equals 0.5 to this exponent t over 10. So now all that's left is to figure out what that exponent has to be. So if you've watched my other exponential function videos, so question 11 and 12, you'll see that I sort of follow the same pattern. First of all, I'd like to simplify my exponent. So right now the exponent is this kind of funky looking weird fraction, and I prefer to think of it as just a single exponent. So if I can solve for x, then I can come back and figure out what t is. So I'm going to rewrite this with just exponent x. And then how do I find that exponent? Because literally, there's nothing else to do but figure out that exponent. And again, if you've seen videos for question 11 and question 12, you'll see that there's really two methods. One method is guess and check, and the other method is using something called logarithms. Now, logarithms is technically a grade 12 topic, so if you haven't seen it already, don't worry. I'll show you really quickly how to do it. It's just a simple calculator trick, but just follow the example of what your teacher actually suggested that you do. So here's what guess and check would look like. I'm going to predict, or no, I'm going to guess at some values of x. And then I'm going to calculate what 0.5x is and see how close I get to 0.005. And as I guess and check, I adjust my guess. And this is valid only if you record exactly what you're guessing and checking. So I'm going to try x equals 3 just to get some sort of starting point. So 0.5 to the 3 is 0.125. So I've got to go bigger. Let's go 10. So 0.5 to the 10 is 0.00097. So now I'm way too small. So somewhere between 3 and 10. Let's try 6. So 0.5 to the 6 gives me 0.016. So how am I doing? So this, I need to have another, so this is too big still. So let's try 7. So 0.5 to the 7 is 0.0078. Still a little too big. Let's try 7.5. And again, how precise you want your answer to be, the exact precision with which I'm able to guess and check depends on how much time I have and how much I think my teacher wants me to spend on this. So that's not bad. I get 0.0055. Pretty close. Just for kicks and giggles, let's see what happens if I try 7.6. And by the way, I haven't done this in advance, so I'm actually just figuring this out myself. Ah, the joy of discovery. Math is fun, right? Ooh, look at that. So this is 0.005 and a little bit. So I'm pretty happy with that. So at this point, I would pretty confidently say I'm done guessing and checking. I would say that x equals 7.6, but don't forget, I wasn't trying to find x. I was trying to find t. So I need to go back and figure out what t is now that I know a good value for x. So don't forget to do that if you follow my method. So I know that x is equal to t over 10, and now that I know that x is 7.6, now I can solve and say that, oops, now I can say that t is 76 days. Okay. Now what's the other method? Well, the other method involves logarithms, as I said. I don't know if you're getting these weird messages, but my battery's low on my computer, so I'll finish. The other method is to use something called logarithms, and again, if you want to see more about them or hear more about them, hopefully you've watched videos 11 and 12. The key to logarithms is a button on your calculator that says log, L-O-G. It's short for logarithms, and to solve for x, all I have to do is take the number that I want on top. So log 0.005, and what I put on the bottom is the number that's actually the base, and that's how I remember to do it in the proper order, that the bottom number was the base. And then I just type this into my calculator. So log 0.005 divided by log 0.5 is 7.64. Haha, I was pretty close. And again, if x is 7.64, exactly like we just did, solve for t. So t would be 76.4 days. I got that through guess and check. It just took me a little while longer. Okay, I hope that was helpful, and I'll see you in the next video.